Yes, hello everyone, and welcome to my stream. Today we have a Electron launch with a few CubeSats from two Lemmer from Aspire Global and the Irvine 1 CubeSat, or a satellite for TVAC. One for one Nabedo satellite and a fleet space technology. There are more, and that's it. And today the countdown for the Electron started at T-minus 7 hours, and it went through to where we are now. We are currently 20 minutes for launch. So at 2 hours before launch, they started fueling. So that is now 9 hours or 1 hour and 40 minutes ago. They started fueling the rocket, and it is fueled now, and it's on the pad, and hopefully everything is gonna go all right, and then we'll have liftoff in just under 19 minutes. And the first stage will fire for 2 minutes and 33 seconds. So it will shut off. It will separate 3 seconds later. Then 3 seconds after that, the second stage engine will fire. And that will fire until 9 minutes and 9 minutes and 5 seconds after launch. Then we will have the kick stage. They have the kick stage on the rocket. They will separate, and that will fire 51 minutes after launch, and then that will shut off 52 minutes and 45 seconds after launch, and then at 54 minutes and 10 seconds, all payloads should be separated from the launch vehicle. So let's see.
And I'll be taking you through today's Electron launch. Thanks for joining us. Earlier today, I checked in with our meteorological operator and found out that our weather looks great for today. We're watching the ground winds, but as for now, we are clean and green.
There we have it.
We are in an exciting new era of small satellite technology.
Rocket.
One that's making
so what
Earth
you see the white part, white on the outside of the rocket is actually the ice.
To connect with each other, enable us to protect people and resources, and they create opportunities to innovate and explore.
I just saw Rocket Lab has started, but I want to give my info.
Its business time features a variety of payloads, including several weather monitoring spacecraft, Australia's first commercial CubeSat, and a drag sail that can produce space.
The Electron is special because it uses electrical turbopumps instead of gas-driven turbopumps. And in, let's say, the Falcon 9, the gas or the turbines are powered by a gas generator, which also uses RP1 and liquid oxygen. This rocket uses liquid oxygen and RP1-2, and RP1 being the rocket-generated kerosene. But it doesn't use the gas generated by burning a tiny bit of the oxygen and RP1 for creating gas and drive the turbines, but it uses electrical power. And the turbopumps of the motors connected to the turbopumps are only
2 Fleet Proxima satellites, and then the TIVAC spacecraft for geo-optics. Another 50 minutes after that, the HPS Nabeo drag sail will be extended, at which point all covered
well, at least you can see what I'm doing.
Earlier this year, on our first orbital mission,
excited for launch. Yeah, I'm excited too. Although you can't hear me.
Data and analytics company Spire.
But this rocket uses
two Lemur 2 spacecraft.
turbo
Spire's
pumps,
primary
but the
mission
motors,
involves the
they
collection
are not
of commercial
bigger
weather data,
than a
as well as enabling
soda
ship
can,
tracking via
but
their
they
automatic
produce 50
identification
horsepower.
system, or
Both they
AIS.
have two engines, one
The team
for the
at Spire
RP1 and
have
one
shared a
for
brief
the
video with us for today's
liquid oxygen.
webcast.
But by using these electrical engines, they have more efficient engines. The engines are actually more efficient than the Merlins on the SpaceX rocket. And
since Spire's first
also,
lemurs, we've gone through 16 batches and 16 iterations.
So for
kind of
the same amount of fuel, they get
payload,
more speed,
which has increased our performance 10x.
Although the engines don't have as much thrust. But they use electrical power, which has one downside, and that is the
external
batteries.
vendors for these services. We can crank out a design.
The batteries take up a lot of power.
Go back to the lab, tweak the design,
but on the first stage, the battery that has to power 16 motors.
This is Spire's
No, 18 motors, sorry, produces 1 megawatt of electrical energy, which is
Spire's own RF chamber.
a lot.
We use this to test and characterize the comms link and the payload sensitivities. Having this capability
So this
on
is
site
one of
along
the
with thermal vacuum and vibration testing cuts weeks out of the manufacturing
this is not the
cycle.
satellite
If
that's on
someone
the
brought us
rocket,
a new
but
sensor tomorrow,
this
depending
is
on how
the
large and complex it was,
Lemur,
something a bit
one of the
bigger,
Lemur
it'd be 4 to 6
satellites
months, but for
that
something
is on the
small and
rocket.
easy, as few as we would.
There are two
Having all
of
these
them.
capabilities in-house brings the time to make a satellite from months down to weeks. EMC testing in-house alone brings something that used to take us a week down to only an hour. What this capability means for customers is that we can improve our satellites more quickly, which means they get better data and more data faster.
Here in Auckland Mission Control, our launch team has just conducted the final go, no-go poll for launch. We are go for launch of its business time. We have approximately 14 minutes until
Flight of the
T0.
Conchords. I don't know what Flight of the Conchords is, but I think part of it is because it's the first commercial flight, and therefore it being business time. And last year, I don't know when it was, but there was they asked on Twitter what should be the name of this flight, and everybody voted for it's business time, and I think it's the most fitting name. And this rocket, by the way, is only 16 meters tall, so it's not that big. But it can lift 250 kilograms into orbit, and this launch is going into a 500 by 500 kilometer orbit on a polar orbit, which is 85 degrees tilted to respect of the equator. Paste my stream link here. Yeah. And they have a so-called business time. I don't know, but I know it was chosen business time because people on Twitter voted. So that's all I know. Maybe Rocket Lab chose it because of that.
One of the final
series
steps of
and
our
that
pre-launch
song.
preparations is the retraction
That
of
could
the
be,
strong
but
back
I don't know.
assembly. At this time, we have opened the top clamp and will be retracting the strong back by 22 degrees. Electron is fully
So
supported
that black
by 4
part on
hold-down
the
points
back of the
and
rocket
fed
that's
by
called the strong
HVAC
back.
and electrical umbilicals.
Has the same function as on a Falcon 9. So the rocket is underneath here, and they carry it out to the pad, then lift it up, and then the arm supports the rocket. And right now they opened the clamp and they are retracting the rocket. Okay, I'm definitely gonna check it out. 11 minutes now, so yeah. And also, these engines can be turned off really quickly. They only take 1/3 of a second to switch on or switch off, which also means that in normally you have sensors in your propellant tanks, and when it gets to a certain level, you need to shut off your engine, otherwise your turbo pumps are gonna go without fuel, and they basically get destroyed. But when you are when you have the Electron motors, you can shut it off actually right when it would hit your turbo pumps, because, well, you can switch it off within 1/3 of a second. So yeah, so you will see at the end of the second, or halfway through the second stage burn, that there are 2 silver boxes on the outside, and these are batteries, and these get
Our launch site
hot
really
swapped.
is that beautiful.
So that
Since
means
we have a little more time before liftoff, we can share some more information
engine,
about the other
engine is
payloads on
taking
board
power
its
from the
business time.
external 2
The
batteries,
Cicero-10 spacecraft
but when they
from
hot swap, they go
GeoOptics,
to the
manifested by
batteries,
tieback,
which is
brings
actually
another
on top
commercial
of the
weather
stage,
satellite onto Electron.
within
Joining
the
Cicero is the
flight
Irvine
avionics,
01 spacecraft,
and they
built by a
eject
collection
the
of
2
high school
batteries on the
students from
outside,
6
and you
different
will
schools
hear
in
them
Irvine,
call.
California. This is the first in a series of
You will
CubeSats from the Irvine
hear them
CubeSat
say
STEM program,
hot
which
swapping,
gives
and then
students
you will see
first-hand
those 2
experience
silver
in
boxes
spacecraft
come off,
design,
which are
operation,
are
construction,
the
and
batteries that
exposure to
being
payloads.
ejected. And
The students in the program prepared a video to tell us more about Irvine
yes,
01's
I
mission.
made a rocket of the Electron, but I couldn't find it. I put it somewhere,
When
but
I first found out
but
that
I
we were going to send
can't
something in
find it.
space, I couldn't believe it. And here we are about to do something big that I've never seen before in any high school.
CubeSat is a type of miniature satellite that's used typically for space research.
What happens is it goes in with a larger project.
And detached at a certain point, and it'll go on its own orbit.
Be able to go ahead and work towards a common goal of having a successful flight,
And,
I think
yeah.
is just really unique for our district, and
So,
our students are ready. They're ready
in
to go ahead and take
that
on
picture
something
you
like this.
see
This will
saw
put
a
Irvine on the
silver
map globally. We will
box
be,
on
very,
one side
important
of the
program
engine,
moving
and
forward
that
for all
was
eyes to watch.
one of the batteries that gets ejected somewhere along the flight.
We also had a last-minute addition to the It's Business Time manifest. Australian company Fleet Space Technologies have 2 Proxima satellites on board. These spacecraft will form the foundation of a global Internet of Things communications constellation to provide internet connectivity for millions of sensor devices in remote locations across the planet. Applications for Fleet's tech are almost endless and range from precision agriculture and virtual fences to maritime logistics and mining. What's particularly exciting about these spacecraft is the speed at which they were manifested. They joined Electron in record time, with payload licensing and full integration complete in just 2 months. Now the final payload on Its Business Time is the Nabeo drag sail from HPS of Munich, Germany.
And
The Nabeo is designed to help passively deorbit satellites at their end of life by increasing the amount of drag
so
the spacecraft
the
experiences. This lowers the spacecraft's
tube that you
altitude
see
and
is
drives
an
it back into the Earth's
umbilical which
atmosphere,
connects
where it burns up
the
on
second
re-entry.
stage and
Innovations like this will play a significant role in reducing space
payloads.
junk in low Earth orbit. For
It's
today's
an
mission,
electrical
Nadeo will
connection,
be
and it
hosted on the
probably
kick stage,
carries
but will not
the
separate from
fuel
the
to
vehicle.
it. It's fuel and electrical connection, and that you will see that fall away and get burnt to pieces when the engines go by. But it's just an electrical connection which gets terminated and disconnected upon launch. At the bottom of the rocket, you will just before launch, you will see a lot of water on the pad, and that is not. It's partly to keep the pad cool, but it's mostly to damp the sound of the rocket, because the rocket creates a lot of vibrations, and if they wouldn't spray it with water, the pad would get destroyed.
To proceed and currently remains go for launch.
And we're just coming up on 5 minutes to launch.
Stand by, LC.
And hopefully you will.
LC, FTS mission code.
Yes.
I can confirm that FTS is green and go for launch.
Yes.
Thank you. And to all operators, there should be no red
While
flag
the
on
Electron,
launch
which you see on the launch pad, is launched in New Zealand, the majority of the vehicle, including the engines and avionics, are produced in Huntington Beach, California, in the United States. The 3D printed Rutherford engines start their life in sunny California, where they are assembled and then shipped to New Zealand for testing and integration into the vehicle. Final assembly and testing of vehicle components occurs here in Auckland. When completed, the Electron makes its way by road to the Mahia Peninsula and Launch Complex 1. Our launch site at LC-1 was designed by Rocket Lab and is the only privately
I think
operated
everyone is green, so we might see a launch today.
Next year, Rocket Lab will
Finally.
begin launching from its second launch complex, Launch Complex 2, currently being constructed at the Mid-Atlantic Regional Spaceport at NASA Wallops on the east coast of the United States. Let's turn over to our control
So you
center
might
audio
remember
and follow the remainder of the count.
a few Antares launches, and this rocket is going to launch from the same launch site, not the same pad. It's a few
we are go for auto sequence
100 meters
T-2
next to the pad,
Copy, locking
but
auto
they will
sequence.
build a second launch pad so they can launch the Electron from there, which is really cool. In my opinion, it's really cool. And a terminal count starts at T-minus 2 minutes. So we're just a minute away from starting the terminal count.
3 minutes and counting.
And terminal count means that the computer takes over, computer checks everything, and if something should come up, and the computer detects something that's wrong, it will stop the countdown. But this also means that once they, if something within these 2 minutes happens, then they need to go back to the T-minus 2 minutes point. And being Rocket Lab, I think they go even further back into the countdown. So yes, hopefully a launch today. Let me check my Twitter again.
Avionics LC on mission code, please confirm all ALV bats have been switched to internal power.
Vehicles on internal power.
And RCO confirm ground power has been disabled on all 3 stages.
I can confirm ground power is dropped on all stages.
To all operators, vehicle is on internal power.
So yeah, okay. So the flight batteries are now on internal power. And this sort of white cloud you see come off it is the gaseous oxygen, because in the tanks the oxygen, some of it boils off, and it turns into a gas, and that is then vented through the umbilical to
PLS,
away from
please
the rocket.
Disable anti-geysering and confirm.
Anti-geysering is disabled.
Stage 1, confirm that stage 1 is pressed.
Stage 1 pressed.
Stage 2, confirm stage 2 is pressed.
Stage 2 is
We're
pressed.
under 1 minute.
Fast barge active.
Woo! Whoop whoop.
Deluge turning on.
Pumps on. Deluge running.
Setting GNC states.
"20 seconds. Or
Rereading
now,
engines.
20. You'll see the water spilling onto the pad.
Flight mode.
10, 9, 8, 7, 6, 5, 4,
Ignition.
3, 2, 1.
Liftoff, yes! Woo! What a power. It goes up really fast. Woo. Yeah, we have liftoff. Woo! Go, 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 Electron. Love that. Onboard cameras, even better. Yes. That is really fast. Yeah, it is.
Dynamic pressure 50% of maximum.
And they should be going through max Q around about 1 minute.
T plus 1 minute, flight is nominal.
Max Q is when the speed of the rocket and the density of the atmosphere, because it's quite high up, but it's already there still is some pressure. Creates the maximum stress on the rocket, and then
Stage 1 propulsion still nominal.
There it goes, and you will see the plume expanding, and it looks like a Falcon 9 plume because it uses 9 engines
Dynamic pressure
as
has
well.
fallen to 50% of maximum.
And just 40 seconds
CO2-1
of thrust remaining, and
AOS
33 seconds
station.
remaining of first stage burn.
Minimize AOA.
Minimizing AOA is basically sticking to the prograde factor, so the second stage isn't doing weird things once they separate. And
Entering mode burnout detected.
10 seconds.
Time to go 8 seconds. 5 seconds.
And 3, 2, 1. Shutdown.
Stage 1 Miko.
Separation.
Separating.
And
Stage
second stage
started.
ignition.
Propulsion nominal, vehicle is stable.
There you go. Woo! So the silver box you see on the side of the rocket, on this side, on the side of the engine, that's one of the batteries that is going to be ejected somewhere along the flight, and we come up conferring separation.
Separating
Yes, inside views of the fairing. This is really cool. There we go. Wow, beautiful. Those fairings falling away. Hi, the launch site is really cool. Looking for onboard cameras. Yeah, that's really cool. Looking at the back at the launch site, I love that. More rocket companies should do that.
Speed 2.5 kilometers per second.
So again, the silver box on the side of the rocket will get ejected once you hear a hot swapping. Once you hear them say hot swapping, this will get ejected. This on the other side. And it should be happening in a few minutes, actually. And what happens is all the electrical power in these batteries get used up, so there's no use to keep them, so they get ejected.
Flight remains nominal.
Stage 2 propulsion remains nominal.
Yes, everything is nominal. The nominal reminds me of the Antares nominal launch. It's really
coming up on
it's
3
really funny.
kilometers per second.
Still have a way to go if they are at 3 kilometers.
Altitude is 200
per second.
kilometers.
Can we spot Peter back over in the control room somewhere? And any minute now they should be hot swapping. And you will hold that calling corner. You will hear the call coming up on hot swap, and then seconds later hot swapping, and then poof, you'll see them get ejected. Mau, hey kitty. Just opening my doors. Come. Yeah, Mau. It's my cat. Yeah, I hope. Please hot swap.
Hot swapping.
There you go, hot swapping. You'll see them get ejected. Poof! There you go.
Stage 2 propulsion still nominal.
The Electron is unique in that its Rutherford engines are driven by high-performance, brushless DC electric motors and lithium polymer batteries. What you saw a few moments ago was the ejection of 2 of our 3 battery packs from the second stage. This is done to increase performance by reducing the amount of spent mass that's carried to orbit.
We're 2.5 minutes approximately from second stage cutoff and the kick stage separating. The kick stage, by the way, uses green propellant, and they haven't told us what it is, but it is a monopropellant.
Flight tailsafe is disabled.
Flight copies.
And
60 seconds.
This propellant is not toxic unless mostly for monopropellant engines they use hydrazine, but this is really toxic, and in this case they use a green propellant, and they haven't said what it is, but it is not toxic. and it's a monopropellant engine, and that is what is on the Curie kick stage. Just 20 seconds remaining now, and we have 10 seconds remaining. Okay.
Engine shut down.
There you go. Ooh. I think that was a little early, wasn't it?
Transfer what looks nominal.
But
and that successfully completes the first half of our flight with a successful orbit injection. Electron's kick stage has separated from stage 2 and is now coasting as planned. The Electron kick stage makes up the final stage of the launch vehicle and provides Electron the capability to precisely inject customer payloads into their final designated orbit, as this graphic explains.
Oh, there you go.
Range copies, IP lifted.
Let's see. What cool graphic.
While stage 2 reaches an initial parking orbit, as shown here, the kick stage completes the mission.
So it's
first, the kick stage is separated from Electron and then performs a 42-minute coast. At 51 minutes into the flight, the kick stage will be ignited and will circularize the orbit, at which point all of our customer payloads will be deployed. As good stewards of the space environment, our kick stage design is such that the Curie engine can perform a deorbit maneuver to enable it to re-enter the Earth's atmosphere faster and burn up, therefore reducing space debris.
Yay! Gotta love them deorbit burns and space debris avoidance. Ooh.
As the kick stage enters its coast phase, we're going to transition over to our tracking graphic, which will show the location of the kick stage as it coasts over the Earth. We are currently southeast of New Zealand, with the clock, and when the clock reaches T+45 minutes, we'll return with commentary coverage.
I wonder if I can see this.
If you've been staying up late to join us,
if you want to know where I live,
if you're planning on staying awake, enjoy these sweet
I live
tunes
here.
From Tim Dodd, the everyday astronaut.
I live here, and the rocket is coming over here, so I probably could see it coming over my head. That is cool. They're using Tim's music, I think. Well, yeah. I wonder if I can see it. Should ask. That is cool. Wow. Yeah, so we have to wait for 42 more minutes. But I really wonder if I can see that. That was really cool. Yeah. So their orbit is gonna go over. Which ground tracking station is that? So probably the engine will fire again somewhere within these two tracking stations. so they can get the data. But that means that it is firing within an hour, within 30 minutes from now. And I wonder if I can see it. Posting something on Twitter asking. Let's choose a sticker that they know where I am. Someone fly me to New Zealand, yes. I want to go to New Zealand too now. Oh. So yeah, I'm gonna put my live stream on pause, and as soon as I know a answer to so I will be back when they fire the second stage engine. In the meantime, enjoy the rocket. Let's change
Bye.
So yeah, see you in about 20 minutes.
ignition of the kick stage and delivery of the payloads to their final mission orbit. Since reaching orbit, Electron has traveled over the South Pacific, across the expanse of Antarctica,
Hi
and
again.
the South Atlantic, and up to the western
So
coastline
we're
of Africa
back
and
for
Western Europe.
another bit of coverage. I just checked outside and it's cloudy and raining, so I won't be able to see it, sadly. So I hope we get some image from the satellite, from the onboard cameras. That would be cool.
Currently, Rocket Lab is standing by to reacquire telemetry. Flight is still nominal.
AOS at Azores Station.
Ah, yes. So they got the signal on...
Our mission operators are closely monitoring vehicle telemetry, which was recently reacquired through our ground station in the Azores.
They got the Electron in the... Hopefully we'll get some footage from the onboard cameras that I'll just wave to the kick stage. Bye.
Rocket Lab is ramping up our launch cadence with multiple missions manifested for 2019 and beyond. There are a variety of job postings on our webpage, rocketlabusa.com, for roles in New Zealand, California, and Virginia. I hope everyone that has dreams of spaceflight will check them out.
So yeah, let's check what launches next. So this Curie upper stage has a engine which uses green propellant, and they haven't said what it is, but it is basically a monopropellant, which is not toxic. And I see Peter back there in the background. I spotted him. No import images. Sad. You can see something happening in the background.
In all stations, we have confirmation of stage 3 ignition.
The kick stage ignition has been confirmed, and the vehicle is now performing a 1-minute burn.
Kick stage. I hope we get some images from.
And we've had stage 3. Cutoff, engine cutoff.
Kick stage shutdown confirmed. We are about to begin the payload deployment sequence. The following is a simulated video of our deployment sequence in real time. The first payload to be deployed is Irvine 01, followed by the 2 Spire Lemur 2 spacecraft, the 2 Fleet spacecraft, and then the Tyvak Geooptics Cicero 10 spacecraft.
Cool. Ooh, I love this. Oh, this is great.
They're celebrating in Irvine, California, a simulation of the Irvine 01 deployment.
This is cool. This is way better than Ariane space images. This is they have the best images. This is
now you'll see 2 payloads being deployed at once. These are the Spire Lemur 2 spacecraft, both being deployed out of Rocket Lab built Maxwell containers. Now we have deployment of the 2 Fleet Proxima spacecraft out of a Maxwell container built by Rocket Lab.
Ooh, I love this. I wish more companies would do this.
And now for the Cicero 10 deployment. And that completes deployment for all payloads. The final activity for the mission is to extend the Nebeo drag sail. However, this will take place almost an hour from now. So at this point, we're concluding today's webcast. This successful commercial flight represents the first of many, with multiple missions ahead for Electron in 2019 and beyond. The timing of our next launch, the Alana 19 mission for NASA, will be announced officially on our social media streams in the coming weeks. Thank you so much for taking the time with us today and for joining us on this journey into commercial operations. This is Rocket Lab Mission Control in Auckland, signing off.
Okay, let me change this. Yeah. Everything. No. Yeah. Yeah, that was cool. Oh. Why are you not working? there it is. Yeah, okay. Tiny hiccup at the end of the stream. So thank you for watching, and as always, like, subscribe, share, and if you'd like to support me, go ahead over to Patreon, patreon.com/alcoholistella, and you'll find everything there. So yeah, next launch that I will be hosting is probably gonna be the Falcon 9 taking up 40 what was it, 70 CubeSats on the whole rideshare mission. But follow me on Twitter for more updates, and of course my paper modeling stream. So the probably my first line, my next stream is going to be next week, but follow me on Twitter and stay tuned for that. And as always, see you later, and ad astra to the stars.